DML statements are an essential component of database interactions since databases are a large part of our daily life. Each activity that we perform throughout the day has some component of the database affiliated with it. Browsing through web pages, connecting to e-commerce website, and even booking a doctor's appointment. All these have a database which has to be accessed to provide data to the user. These indirect user database interactions are possible due to a specialized coding that allows data to be inserted into, modified, or deleted from the database, and that is where DML statements come into the picture. DML stands for Data Manipulation Language. It is a SQL language that is used to retrieve and manipulate data. You can use these statements to do things like add new rows, update and delete existing rows, merge tables, and so on. So if you feel the need to dig deeper into DML statements in SQL, sit tight as we bring to you all the information you need right on your screens. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.
Hello everyone. As we already know, database is a large part of our day-to-day life. This means that in each and every activity that we perform, be it logging into our social media accounts, actually going and setting up an appointment for an RT-PCR test, or even handling a doctor's appointment. In all of these cases, we always have a database at the back end, which is actually going to store the data, is going to retrieve the data as and when required, and is also going to modify the data in such a manner so that whatever day-to-day activities are taking place are accordingly updated within the database. Right? So how is all of this done? That is going to be the agenda of this particular course. We are going to look into how data is inserted into a database, how it can be modified within the database, and how the data can be removed or eliminated from the database. So let's quickly get started. So for this particular course, we are first going to look at what DML statements are, what are the various types of DML statements, and lastly, we'll be looking at the difference between two types of statements, namely the DML and the DDL statements. Next, we're going to look at all of the syntax and examples as well as practical implementations of the insert, update and delete statements, which are actually a part of the DML statements. We're going to look at all of these statements in the form of the MySQL database. So let's quickly get started with the course. So these DML statements are actually a part of what we know as SQL. SQL stands for the Structured Query Language, right? Now, what does the structured query language do? It's actually a pretty basic language which helps us in structuring data in such a manner that using queries of a certain given format, we can retrieve, update, modify, basically manipulate the data in whatever way we require. Now, what is DML? DML is actually one of the subsets of queries which are known as data manipulation language. It's obviously a subset of the SQL queries. What it does is it helps us in manipulating the data which is inside the database. This is a very specific definition of the data manipulation language. It is what sets DML apart from the rest of the type of queries that we have within SQL. For the purpose of this particular course, we will be implementing all of our DML queries using the MySQL database. Please make a note of this, since using different kind of databases might lead to small changes in the syntax that is being utilized. For example, you would have a semicolon or would compulsorily require a semicolon at the end of every line in MySQL, but this is not necessarily required for SQL Server, right? So please make a note that any and all syntax that will be taught in this particular course is going to be from the point of view of MySQL. So there are three basic types of DML statements. The reason I'm saying that there are three basic types of DML statements is because there are other more advanced type of DML statements which are often applied in relation to DML in order to ensure that these statements work or execute properly. Now, the problem with those statements not mentioned here is that they're often applied with many other constructs in databases also. So in order to keep this as clear as possible, I have considered these three. So first we've got the insert statement. Insert statement is actually the DML statement that helps us include new data in the form of rows. Newer data will constantly keep coming into a database on a daily basis or even for that matter at a millisecond basis, right? That is because any user is going to constantly interact with the database either directly or indirectly throughout the world at any given point of time. This means that each and every time a user interacts with, say for example, your website or application, the user is indirectly interacting with your database. Their data would actually have to be stored in the database. This is done in the form of rows. Next, we've got the update statement. Update statements help us modify certain values within the database rows based upon some conditions that are provided. So this means that the update statement will ideally have a place where you're asking for the update, a place where you're modifying a value that already exists, and lastly, it will have a position where the condition of where the modifications have to be applied are also mentioned. Lastly, we've got the delete statement. The delete statement is one of those DML statements that is rarely used. The reason for that will be explained while we actually go through what delete statements are in detail. Now, delete statement again work slightly like the update statement. They help us delete rows from certain tables based upon a condition or a parameter, right? So again, this means that we'll have a query where deletion has to be performed with whatever rows need to be deleted based upon the conditions. All of these parts will actually be seen in detail while we go through these statements. Lastly, let us look at the difference between DML and DDL statements. In order to understand this difference, we need to first understand that SQL as a language actually has various parts. We've got DML, which is the data manipulation language. We've got DDL, which is the data definition language. We've got DQL, which is the data query language. And we've got TCL, which is the transaction control language. DML is charged with manipulating the data. DDL is charged with defining and creating the structures within that database. DQL is data query language, which is charged with actually retrieving and querying the data that is present in the database. Lastly, we've got TCL, which is transaction control language. It actually helps us maintain the integrity of the complete database while also coordinating between all of these various queries. So SQL on the whole consists of all of these various subsets of queries. Now, why is there a confusion between DML and DDL? Because the definitions of the two very closely resemble each other. DML on one hand is where we actually manipulate the data. On the other hand, DDL helps us manipulate the data's structure. This is one of the most important differences between DML and DDL. In both cases, we are able to insert newer entities, update existing entities, or delete existing entities. The entities that we are actually manipulating is what makes a difference. If we are working only with the data, it becomes DML. If we are working with the structure, for example, a table, a relation, or even for that matter, a complete attribute, then the language is going to be DDL, that is data definition language. Let us just quickly go through the pointers here. So first, DML stands for data manipulation language. We are able to add, delete, or update data from within the database constructs. Here, constructs actually stands for any entity or structure that might be a part of our database. Next, while actually creating the queries or typing down the queries, the table name is the only thing that is used along with the where clause. We'll be looking at this in some time as we look at the practical implementations of these statements. On the other hand, DDL is the data definition language. It is used to create, modify, or delete complete database elements, which will often lead to a change in the schema or the structure of the database. Lastly, we have a specialized keyword table that is used in the query as a means to state that any of the changes, may they be creation, modification, or deletion of existing entities, are to be done for this particular table name or entity. So this is the difference between DML and DDL statements. So let us now start with the first type of DML statement, namely the insert statement. So the insert statement is one which helps us in adding new data into an existing table in the database. Now this data is added in a row-wise or what is also known as a tuple-wise manner. In different places from different instructors, you might have heard different pronunciations of this term. It can be known as tuple or tuple. In any case, it means that we are considering a complete row of the table. By default, insert statement is on auto commit mode within MySQL. So what is the auto commit mode? Commit is actually a statement in SQL that helps you completely save the instructions that you have passed on. So any query that you fire in a database will have to be committed in order to save the changes to the database. In MySQL, this commit statement is considered as default. So any and all insert statements that you fire in MySQL are by default committed as soon as you execute them. What happens if you do not want this to be the case? What happens if you want to wait till multiple insert statements have been executed completely and then you want to save it? It's simple. You need to set auto commit to false. Once you set auto commit to false, you will see that none of your insert queries are being saved into your database. After you're done with executing multiple insert queries, you can now execute the commit command explicitly, thereby saving all of the values or all of the insert statements that came before. This is what auto commit means. For the purpose of our implementation, we will keep the auto commit set as default, which is true. Next, let us look at the syntax of the insert statement. The insert statement has two keywords, very important, which are here. First, we've got the insert keyword, which actually defines that the query is for insertion of data into a particular table. The into keyword helps us define which table we are concerned with. The table name is not a keyword. It is actually the name of the table that we are currently working with. After the table name, we have a set of column names belonging to the given table. We're supposed to put this up as and when required. There's a variation here which we'll be seeing later on while we do the hands-on for this. Next, we've got values, which is again a keyword. The values keyword helps us form a relation between the columns and the corresponding values given for those columns. Lastly, we've got the set of values that we want to insert within the column. Please note that each and every column corresponds to its respective value. So this means that column 1 will have the value of value 1 stored within it after execution of the insert statement. Similarly, column 2 will have the value of value 2 stored in it, and column n will have the value of value n stored in it. This is how the insert statement actually works. So let's quickly go on to the hands-on to understand exactly how the insert statement works. So here we've got the MySQL command line interface switched on. The first prompt that is given here is for the password. Whatever password you have applied during installation has to be inserted here. On doing so, we get a complete idea about what kind of copyrights are there within MySQL. Now, since MySQL is a part of Oracle, even the affiliate is given here. Next, we've got this MySQL prompt that actually is where we start typing in from. Now, what are we supposed to do from here? In order to work with any table in MySQL, we first need to put that table into the database. So let us see what are the different kinds of databases available within MySQL. So in order to look at all of the available database, we have a query called show databases, right? Remember that each and every query that we have here in MySQL will require a semicolon at the end. What happens if you don't put a semicolon? You get a line asking you to continue with the query, right? That is what that tiny arrow there is. It's asking you to continue with the query to bring it to completion such that it can be executed. Putting a semicolon completes this particular query and thus it executes. So as we can see, we've got 5 different databases given here. We've got information schema, MySQL, performance schema, sys, and test. Now by default, most of you will have just information schema, MySQL, performance schema, and sys. This test database is something that I have created. How do we create a database? Creating databases are very easy. We just create database with its database name. That's done. Let us check if this particular query has been executed. So now as you can see, we've got, apart from our original databases, a new database called test1. This is how you can create a database. Next, we need to use a particular database that we've created. We simply type use followed by the database name. For the purpose of this particular example, I'm going to use the test database. Type in this command and click on enter. A database changed statement is shown here, indicating that our database has been changed to the test database, and now we can create any kind of table as and how we require. So let us create a table employee as follows. Create table followed by the name of the table, and next we give the list of attributes that are to be contained within the table. So first name of varchar, which will take up to 20 characters. Last name of type varchar, that will again take up to 20 characters. Age of type integer. Mobile number of type char of 10, salary of type integer. Right? So this is how we are creating our table. We've got first name, last name, age, mobile number, and salary. This shows us that this particular table has been created. If there were any errors, we would actually get those error messages in this particular place. Since it's given us query OK, it means that the table has been created, and the 0 rows affected actually means that there are no particular rows within this table currently. So the query has been executed, but there are no rows. Let us now see how we can understand whether this table has been created properly or not. We can use the describe query. Describe employee. So what does the describe query do? It just shows us a complete description of what your table schema is, right? The structure of the table. So here we've seen that we've created a basic simple table having no primary key, having no other constraints in it, except that we've got a certain data type that needs to be entered into it. Now, many of you might ask why mobile number has been taken as a character of 10. Well, it's pretty simple. If you think about it, mobile number actually just has 10 digits in it. Instead of actually giving a larger value like big int, which will obviously take a larger space in the memory, we can give char, which will take a smaller space. Another thing is that you're giving a limit to the acceptable number of characters that can be a part of mobile number. We are giving 10 characters, therefore the database will accept only those values that have 10 digits one after the other set in the form of a string. Next, let us see what are the contents of our table. So we execute the query, select star from the given table, which is employee. Please note that this is not the healthy way of writing a select query. Star, or the all attribute given here, is supposed to be almost never used. But for the purpose of this particular demonstration, I will be using it. As you can see, on actually clicking on enter, I get empty set. This is because currently there are 0 records within our table. Next, let us start setting up the records of our table. Let us type in our first insert query. So we've got the insert keyword, we've got the into keyword, we've got employee. Next, we've got the list of column names. So we have first name, last name, age, mobile number, and salary. Let me just quickly put a space here. This will be followed by the keyword values, followed by the actual values that we need to insert here. So we're going to insert first name, say for example, Radha. We're going to insert last name, say for example, More. Next, we're going to insert the age. Next, we're going to insert a mobile number, which is just 10 digits, right? Next, we're going to insert the salary. And we click on semicolon. Can you see this? So now it's giving us that the query is okay and one row has been affected. Now, what is this one row affected? This actually means that this particular query has been inserted into the database. So whatever data has been given here has all been inserted into the table that we had. Let us check if this is true. Again, we fire the select statement, and as you can see, we now have a complete table with one row inserted within it. Now, this form of writing a query becomes a bit tedious. Since we have just 5 columns here, it's easy enough to put all of the column names and the related values. What happens if you want to put in values into 20 attributes that might be a part of your potential table? So there are actually two ways in which we can insert queries into any table. On the one hand, we've got all the values, and on the other hand, we've got a list of columns and values. So can you see how it's different here? We can either use the insert query with only the values, or we can provide the insert query with both the columns as well as the values. Now, where are these two types used? We'll utilize the values if we want to insert all of the values of any given table. This means that if we want to insert values into each and every attribute or column of the table, then we can use only the values. On the other hand, if we want to insert specific column values, then we can give the specified column names with their corresponding values to our table. Let's look at a quick example of this. Let us first insert a query without having any column names. So let us reutilize our query here. Let us change the values such that we've got a more manageable form. And let us remove all of the column names here. So now our query has become insert into employees without any column names. We're simply stating that the values have to be so and so. As you can see, this particular query has executed without any problems. This is because the values for each and every column have been provided here. Let us quickly check what the table looks like. So we've now got two records given within our table. Next, let us see if we can simply insert the first and the last name without the age of the person or the mobile number or the salary. In order to do that, we are supposed to actually specify the column names where we want to insert data, followed by the actual values that have to be inserted in their place. So this is what it looks like. We've got insert into employees, first name, last name, the two values where we actually want to insert data, followed by the values keyword and the actual values that need to be inserted there. So as soon as we execute this query, you can see that again, this query has fired appropriately and one row has been affected. Let us see how our table looks now. So as you can see, the third row that has been inserted here has just the first and the last name. The rest of the three values are stated as null because there are no values actually inserted there. These are the three ways in which we can actually insert values into our database. Another manner in which we can insert any kind of records into a table is by taking the records of one table and putting them into the records of another table. Let us see how that can be done. Let us create another table, say employee 2. Let the table have column names as follows. This is what the table looks like. So we've got a table created as create table employee 2, first name, last name, age, mobile number, and salary. We have created this table and there are no rows currently as a part of the table. What we are now going to do is that we are going to try to insert our employee table records into the employee 2 records. How is that possible? So let us see. First, we'll write our insert query. Insert into our table name here is employee 2. Next, we're going to put in a select query. This select query is going to be fired on our initial table, which is employee. So we can type select star from employee. As soon as we click on enter, we get a query 3 rows affected. This is because our initial table, which was employee table, had 3 records in it. Now our employee 2 table also has the 3 exact records. Now this particular type of insertion can be done in any kind of form. Till your select query is written here, any data from one table can be put into another table. There is a clause here though. That clause is that the column type of table 1 should be equal to the column type and number of table 2. Till this clause is satisfied, tabular data from one table can be transferred to another table. Tabular data can also be transferred using this particular method from a table in one database to another table in another database altogether. Thus, data can be copied from one table to the other in a batch manner. It is not necessary that the whole data has to be transferred from one place to the other. This is because since we've got a select query given here, we can also pass on conditions for the select query. Here we can say select star from employees where, say for example, the first name is equal to Radha. Right? So we've got a where condition here. Let's see what happens because of this. We've got 2 rows that have now been inserted. Let us look at employee 1 or employee table as it's called here. We've actually got 2 rows which have the first name Radha. Now because of these 2 rows, what has happened is the select query here has actually taken up these 2 rows having the first name Radha and inserted all of them into the employee 2 table. Let us have a quick look at the employee 2 table. So as you can see, now employee 2 has 5 records in it. Yes, we do have duplicates here, but that is something that we'll look into later on. So here we've seen how we can transfer data from one table to the other. In a similar manner, we can also select the column names that we want to transfer from one table to the other. In that case, we need to ensure that the insert into also has a set of column names, and instead of star, we have a set of column names, both of which should be equal to one another. Please make a note that the number and the meaning of these columns have to compulsorily be equal to each other. The reason that here we were able to transfer all of the data from one table to the other was because both of the tables had the exact same column type. Right? So any kind of select query with a where condition, even for that matter, a having condition can actually be implemented here. Till it's a select query, all of the clauses of the select query can be implemented and data can be transferred from one table to the other with only one clause, that is, the number and type of columns that you're selecting from should be the exact same as the number and type of columns you're inserting into. Next, let us dive into the update statements. So as we already know, update statements are used to update a table. So when we look at any update statement, the basic aim is to change or modify the values that are given in any particular tuple of a table. Now, there might be multiple rows or multiple tuples that might have this effect because there is always a where clause given with the update statement. Now, one thing we need to be careful of is this particular where clause. The reason behind that is very simple. It is because this where clause is actually going to define all of the places where the changes have to be made. If your where clause or your where condition is not written properly or defined in, say, an ambiguous manner, then it might lead to possible loss of data or it might lead to completely faulty data. So here it's very important to note that there is a where clause and that where clause has to be very clearly defined. Again, as we have seen in the insert statement, even the update statement is set on auto commit by default while using it in MySQL. So there is no need to explicitly type in the commit statement for the same. Any modifications that is made in the database via the update statement are actually saved into the database at that particular instance only. Let us now look at the syntax of the update statement. As we already know, we've got three parts of an update statement. The first part is the actual query that states that an updation is going to be under process. Next, we've got the part where we are setting the value that needs to be updated and how it needs to be updated. Lastly, there is the condition of where the updations have to be implemented. Please make a note that updations should be implemented with the utmost care, specifically because of this where condition. Now, this where condition again can have a multitude of variations. We can have simple where conditions with an equation where one value is equal to another, or we could have where conditions wherein we are using keywords like between, like, in, etc. So anything and everything that you have ever learned with where can be implemented here within the update statement, because your where condition is going to determine exactly which of the rows and which of the values are going to be updated as per the conditions set. Next, let us look at an example of how the update statement can be used. So for the sake of this particular example, let us take our existing employee to table. We've got 5 records here. Let us create an update query, update table, which is employee 2, and we want to set, say for example, the age of the people. Oh, the age spelling is wrong. So we want to set the age of the people to 18 wherever the age of the person is currently set to, say, 43. So ideally what should happen is both of these values of 43 should be converted into 18. Let us see what happens when we execute the query. It says that 2 rows have been changed. Let us see how these 2 rows look like now. So as you can see, Radha, who was initially 43 years of age, has now been converted into 18. Similarly, Radha, who was of 43 years of age below, have also been converted to 18 years of age. This is how the update query actually changes. Let us look at another example of the update query. Say, for example, I want to change the first name. So I can write update employee 2 set first name is equal to Rana, where salary greater than 33,000. So can you see what has happened here? What I'm doing is that I'm setting the name as Rana for all of those people whose salary is greater than 33,000. Let us see if this particular query executes. So it's saying one row affected. Let us check what our table looks like now. So as you can see, there was only one person with a salary greater than 33, and that person initially was Radhika. Now, because of our update query, it has been changed to Rana, right? So as you can see, the update query here can actually work on two different column names, wherein you are setting the value of one column and you're checking the clause from another column. Now the where condition, as we've seen, can have different kinds of clauses. We can have comparatory clauses as here. We can have combinational clauses wherein we're keeping multiple clauses. Say for example, the salary has to be greater than 33,000, but it needs to be less than 42,000. Right? So these kinds of clauses can all be a part of our update query. Any clause that you can actually think of can be a part of the update query. So it's not necessary, as in this case, that you have the same column names in both the set as well as the where condition. We can have different column names too. An iteration that I would like to make is please be wary of this particular where clause. The reason I'm constantly stressing on this is because the where clause is the one that decides and defines exactly the place or the location where the changes have to be made. If the where clause is set incorrectly or ambiguously, that is, if there is any confusion regarding exactly what the where clause means, then this will lead to problems with the database that has been modified. So that is how we can practically implement the update statement. Lastly, let's look at delete statements. Before we go into this, let us first discuss why delete statements are not really used. Delete statements are actually those that help us in deleting a record completely from the database. Before understanding the intricacies of the delete statement, let us understand why I keep iterating the statement that delete statements have to be never or very rarely utilized. In any database, data is stored in order to make it non-volatile in nature. This means that we're trying to increase the lifespan of the data. If we keep it in a volatile memory like RAM or a semi-volatile memory like a hard disk, we will have to delete that data constantly, right? Why do we store all of this data in the database? Such that we can maintain that data and archive it for later retrieval down the years. Now, what happens if you delete data? Data that is deleted is going to be lost to us forever. This is something which is not acceptable. So delete statements are rarely, if ever, used. So what is the practical implementation? How do we remove a certain set of records from the table without deleting it? Let us look into it after a few minutes. Let us first dive into the delete statement. So as we've seen, delete statements are going to actually enable the deletion of a complete row from a table in the database. Now, because there is a where condition in delete statements, there will be multiple rows which will be affected based upon the condition that we have provided there. As with other DML statements, we've got a by default auto commit in MySQL for delete statements also. Next, let's look at the syntax of the delete statement. So the syntax of the delete statement is quite simple. We simply delete all of the records from the table where the condition is met. There are no specific values to be deleted here or any specific column names to be deleted here, right? So that is why there are no contingencies for columns or values. It is simply deletion of all the records of a given tuple where the conditions are met. In order to further understand this, let us actually have a hands-on implementation of the delete statement. So let's go on to the hands-on implementation of the delete statement. So for the purpose of this particular hands-on, let us again take the example of employee 2, which we have previously created in this particular session. In the employee to table, suppose I want to delete all of the records that have age as 18, right? So I want to delete all the records where age is 18. The syntax for this is very simple. We write delete from, pardon the spelling, from table, which is employee to, and then we put up the where condition, where age is equal to 18. Now, as soon as I execute this query, this is what I get as the result. The query says that it's been executed and there are two rows that have been affected by it. Let us look at what happens to the table. As you can see, all the records containing age as 18 initially, namely the first Radha and the second last Radha, have been deleted. Let us look at another example here. Say we've got a delete statement for employee to where the salary is or where the salary is equal to 3 or 30,000. So this is what we were supposed to do, right? Delete the record of the employee wherein their salary was equal to 30,000. As you can see, it's giving 0 rows affected. Let us see why that is so. It's because of a very simple reason. It's because there is no employee here whose salary is actually 30,000. So what do? We change our query. Let us change the query to something like this. Let it be delete from employee where salary is equal to 35,000. And now we can see that one row has been affected. So let us check what our table becomes. So now instead of 3 rows, we have 2 Radhas in the row, and the Rana who had 35,000 has been completely deleted. One more thing to take care of here is that most of the time, if you're using a delete query, you have to use it along with a where condition. The reason for that is very simple. Let us look at an example where we do not use the where condition. Let us take a delete statement such that we are deleting from employee to table and we're not giving any where condition. Let us see what has happened. We've got 2 rows which have been affected, but we've not given any where condition here. So which are the 2 rows that have been affected? Let us check what happens to our table. As you can see, not giving a where clause in our delete statement has led to the deletion of all of the records given in our table. There was no discrimination made on which records to keep and which to delete. The complete set of records that were a part of the table were deleted. This is why deletion is not undertaken. Deletion is a very dicey form of query which, even though acceptable to the database, should not be carried out on the database to preserve its integrity. Right? Because if the slightest mistake has been made within the where condition, or if the where condition is not put in by mistake, we lose a large amount of meaningful data permanently. So we've seen how the delete statement can actually be implemented in the database and how it is implemented with the where condition, and also how it's implemented and what are the consequences of implementing it without the where condition. Now, as I've said already, and I'm stating it for the nth time, the delete statement is discouraged. Now, if the delete statement is discouraged, how do we retire or remove any kind of data which is no longer useful to us from the database? Suppose, for example, we have a student who has retracted their admission. Since the student is no longer a part of the university or college that they had taken admission initially in, that record should be deleted, right? Wrong. What we do is, ideally, we put up a new column called status. This status determines whether the status is active or, for this case, admitted. If the status is changed or modified to cancelled, then this particular student is considered as no longer a part of the college. So the data of the student will be maintained in the database. It will persist in the database, but since the status is cancelled, that is why in the further queries that we create, we will ensure that none of the cancelled status students are included in any calculations or reports made. So instead of trying to use delete to actually completely remove the data from the database, we utilize update to modify the records in such a manner so that they are easily excluded from any future calculations or report making. This is how delete statement is implemented within the database. So let us quickly summarize what we've studied till now. First, we looked at what DML statements were. We understood what are the three types of DML statements, namely insert, update, and the delete DML statement. Next, we also saw that there were various other kinds of SQL statements, namely the DDL statement, the TCL statement, and the DQL statements. We saw a set of differences between the DML and the DDL statements. We understood exactly how they were different. We also saw an implementation, a hands-on implementation that is, of the create statement, wherein we created both a database as well as a table. Actually, two tables for that matter. So the create statement was a part of the DDL, which helped us in changing the structure of our database, whereas the insert, update, and delete queries were a part of DML statements, which help us change the data within the structures. Next, we saw the intricacies of the insert statement. In the insert statement, we have three ways of creating or inserting data into any particular table. We could either have a set of columns provided with the values attached to them. Secondly, we could just have a set of values, in which case we will have to provide all the required values within the table. And lastly, we can insert records from one table to the other with the use of select queries. Next, we saw the update statement. In the update statement, we saw that there were three parts to the statement. First, the actual update keyword, followed by the table which has to be updated. Next was the value that had to be updated. And lastly, the condition on the basis of which the value was updated. Lastly, we saw the delete statement, wherein we were very careful to see the two kinds of deletes. One with the condition and one without the where condition. We saw what the problems of both were. Especially remember the where clause. In both update and delete, this where clause is very important. Any ambiguity or confusion regarding the where clause will lead to faulty or incorrect data. Lastly, we saw the reason why the delete statement is not used and what is the alternative for the delete statement. Right? So this is all about the basic three statements that are a part of DML. I hope all of you have understood this very well. Thank you so much for attending the whole course.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.